numbers can get to be very, very, very big. An example. The Voyager 2 spacecraft left Earth 35 years ago. In that time, it has travelled 14,700 billion metres from Earth. It's nearly leaving the solar system. It's right on the edge. But can you imagine if you had to write down that number every single time you were talking about Voyager? That would get quite irritating. Fortunately, we have a shorthand way of doing this. Mathematicians don't like doing things they don't have to do. Quite lazy, really. So we use a thing called standard index form to write out very large or very small numbers to avoid having to write all those zeros all the time. So let's look at how we would write down that number in standard index form. That 14,700 billion metres would be written down as 1.47 times 10 to the 13. The number part on the left is called the mantissa. That's always going to be greater than or equal to 1 and always less than 10. So there's only ever one digit in front of the decimal point. The other part on the other side always has a 10 there, and then the index there, the 13 in this case, is called the exponent. It can be any positive or negative integer. Where it's a positive number, we're talking about a large number, and if it's a negative number, we're talking about a small number. It's quite easy to see where the 1.47 has come from. It's just the numbers from the front of the number up there. The exponent, however, is not so simple to see. But if you were to count how many times we've moved the decimal place, you would find that it's 13. And that's where we get the exponent from. Let's look at an example. Write this number in standard index form. I'm not even going to try and say it. The mantissa is easy, 8.36. It's the three significant numbers at the beginning of the whole number. So now we have to count how many times we have to move the decimal point to move it so that it's between the 8 and the 3. So let's do that. There it goes. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 spaces. We have moved the decimal point by 14 places, and so that means our exponent is 14. So our answer here is 8.36 times 10 to the 14. If you've not managed to follow that completely, go back and look at the video again now so that you can make sure that you understand exactly where both of those numbers have come from, the 8.36 and the 14. Okay, let's look at another example, but this time at completely the other end of the scale. Electrons are very, 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 very tiny. The approximate radius of an electron is that small. I'm not even going to try and say it. So let's convert this into standard index form. Again, the mantissa is easy. That's 2.8. What we have to know is how many decimal places do we get to move the decimal point. So let's write out our number again and count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the decimal point has moved 13 places. But this time it's moved in the opposite direction to before. It's moved to the right. So it's a minus number. So the exponent is minus 13. So our number that we've got at the top there, written in normal decimal form, is 2.8 times 10 to the minus 13 when we write it in standard index form. Let's just summarise what we've got to already. Very big and very small numbers can be written more easily using standard index form. It's just mathematicians being lazy. The mantissa is always between 1 and 10, and it will never be 10. It will be 9 point something something. The exponent is positive for big numbers and negative for small numbers. If you can remember those three things, we're in a good place. Let's look now at how to multiply standard index numbers together. Multiplication is quite simple really. First of all, we multiply the mantisses together. Then we add the exponents. And finally, we adjust the exponent to make the mantissa to be less than 10. Here's an example. We're going to multiply these two numbers together. 1.5 times 10 to the 5 times 8 times 10 to the 6. First of all, we multiply the mantisses. 1.5 times 8 is equal to 12. Then we add the exponents. 5 plus 6 equals 11. Then we have to adjust the exponent to make the mantissa less than 10. We do this by dividing the mantissa by 10 and increasing the index by 1. So we've divided by 10 and then multiplied by 10 effectively. So that means our 12 times 10 to the 11 becomes 1.2 times 10 to the 12. Just to repeat what we've done there, we've divided the 12 by 10 to make it into 1.2. So if we divided our number by 10, we have to multiply it in some way by 10 to get it back to what it was. So that means adding 1 to the index, because that's the same as making the number multiplied by 10. Let's have a look now at how that works with division. Division is obviously going to be slightly different to multiplication in that first of all we divide the mantisses, that's the division part, then we subtract the exponents. In both cases here we've done the opposite to what we did when we were doing a multiplication. So then, having done those two things, we'll have to do the third thing we did with multiplication, adjust the exponent to make the mantissa less than 10. And we'll see how that works when we do our example. So let's have a look. Let's do an example of 2.6 times 10 to the 10 divided by 5.2 times 10 to the 6. So first of all, divide the mantisses. 2.6 divided by 5.2 equals 0.5. Then we subtract the exponents. 10 minus 6, that's equal to 4. Then finally we need to adjust the exponent to make the mantissa less than 10. Those two numbers above give us 0.5 times 10 to the 4. So we've got to make that 0.5 into a number between 1 and 10, which means multiplying it by 10 to get 5. Because we've multiplied by 10, we have to subtract 1 from the exponent to get 10 to the 3. So our answer to our question is 5 times 10 to the 3. Finally, let's look at addition and subtraction. To add and subtract numbers in standard index form, you can either convert the numbers so they both have the same exponent and then add or subtract, or use a calculator. Let's look at the first method. Here we've got two numbers, 4.5 times 10 to the 6 plus 3.2 times 10 to the 4. They have a different exponent, so we cannot add them until we've converted them to have the same exponent. We're going to convert the first number so by multiplying the 4.5 by 100, and that enables us to reduce the 6 to a 4, effectively multiplying one bit by 100 and dividing the other bit by 100, leaving us with the same number. We then add the two mantisses together, and that gives us 453.2 times 10 to the 4. And then of course, to get it into standard index form, we have to make that into a number between 1 and 10. So we divide that by 100, which means increasing the exponent by 2, effectively multiplying by 100 again. And that gives us 4.532 times 10 to the 6. There is a separate video that shows you how to use a calculator to input and manipulate numbers in standard index form. I suggest you have a look at that, particularly when it comes to addition and subtraction, because it's a lot easier on a calculator than it is working with multiplication and division, for example.